Okay, Chapter 5, the title here is Discounted Cash Flow Valuation. Essentially what we're going to do is we're going to look at some more complicated applications and techniques in the time value of money. So let's go ahead and get started. Skip too many slides, sorry about that. If you remember this example in the last chapter, we have a company that's going to invest $15,000 and receive these cash flows. The question is this a wise investment if the firm can invest at 12%? So what we can use, if we go to our cash flow, our time value analysis, if you look at the bottom here, here's the time value of money, but this is a mixed cash flow stream, so we need to go to the mixed cash flow analysis. Let me get rid of some of these numbers here, and we need to incorporate this. So they're going to invest $15,000, so it's a negative number. They receive $3,000, $5,000, $4,000, $3,000, and then $2,000. So there are the cash flows, 3, 5, 4, 3, and 2. We need to change our discount rate to the problem, which is 12%. And what we find out is that this project, the value of the project to the company is $12,553. The challenge with it, though, I think you can start to put the logic together here, is we're going to spend $15,000 to get something that's worth $12,553. So the net effect, what's essentially referred to as the net present value, is a negative number. So the company is ultimately going to lose value, lose wealth with this particular project. So those are the examples, the things that we want to kind of talk about. So here's another example. We're going to expect to receive these cash flows in the future. We can earn at least 8% on our investment. How much will it accumulate by the end of the year? So now we're asking a future value question. If you receive these and you reinvest it, how much will you have at the end? If you think about this as applying the compound interest concept, we do this all the time with our 401ks, our savings accounts, etc. We're constantly gathering funds, receiving money, and reinvesting it. So this is a way to calculate, if you will, how much we would have at an end period. So what does that look like? Whoops, I'm sorry, I didn't want to do that. Here is the example. Again, we can go out now. I want to go back to my spreadsheet. Let's incorporate this. So we're going to get 11,000, 14,000. Oops, too many zeros and not enough zeros. Sorry about that. 10,000. 11,500. 14,000, 12,900, 16,000, 18,000. And our interest rate that we had, that we're saying, is that we're going to get 8%. So here we have our solution again, that the value of this project today is $56,902, but if you reinvest, right here is the answer. If you reinvest, we'll end up with $83,608.15. Now you can do this on a financial calculator if you have a cash flow function. You could certainly do it by hand, as this example kind of shows here. My Hangouts thing is messing me up. But you can do them individually and just add them up. I think the computer is a little bit quicker to get that process done. Again, same question. Now we're working backwards again. What's the present value? What's this company or this project worth if they were going to receive these cash flows? So let's go back to the project, right? 400, 800. Whoops, sorry. Went to the wrong box. 500, 400, and 300. Interest rate we're looking for is 9%. So again, the present value of this project is $19.04. That's what it's worth in today's money. The future value, reinvested in them, it's worth $29.30. What if I were to tell you that you could invest, you could buy this project for $1,500? What solution, or what would you say about this particular project? So if we add the cost to times 0, $1,500, we would find out the what? You'd pay $1,500 to get $1,900. So you would have a benefit. You would be getting more than what you would be paying for it. So again, we can skip forward to the next, go to the next slide. And again, there's our answers. We do it on the computer. We can do it by hand, or you can do it with a financial calculator. The answer is roughly $1,904. Your broker calls and tells you that he has a great investment opportunity. If you give him $100 today, you'll receive $40 in 1 year and $75 in 2 years. You require 15% on your investment opportunities that have this level of risk. Should you take the opportunity? And again, we won't go through the spreadsheet example here, but you can see that obviously that this is a net present value. You're going to spend $100 and you're going to get something worth $91. So obviously the cost of this investment is more than what the value of the investment is. Next, let's talk about some special kinds of cash flows. There's something referred to as an annuity. An annuity has an equal set of payments that occur at regular intervals for a specific period of time. Now, if this first payment occurs at the beginning of the year, then we refer to it as something called an ordinary annuity. However, if the first payment doesn't occur until the end of the year, if it occurs at the beginning of the year, it's an annuity due. If it occurs at the end of the year, it's an ordinary annuity. And the computer, your financial calculator, the tables, if you're using tables, they all assume an ordinary annuity. So you have to tell things if you do an annuity due. There is a special kind of an annuity that's called a perpetuity. And a perpetuity has an infinite series of equal payments. So it is equal payments at equal intervals to infinity. So let's look at some examples and some further exploration of annuities. There are some formulas. The present value of a perpetuity, you take the payment divided by the return. That's a fairly simple formula. Unfortunately, obviously, maybe it's not unfortunate, it's just, we can't calculate the future value of a perpetuity. You can only calculate the present value. But for annuities, we can calculate both present values of the payments and the future values of the payments. Now, I would like to, in my documentation, especially on the spreadsheet, I like to put an A after the V's here, because this is the present value of an annuity. This is the future value of an annuity. It makes it a little easier so you don't confuse the formulas that you might be using in your calculations. So let's take a look at two series of cash flows. We have two potential investment opportunities. Both of them are 5-year, $1,000 annuities. Annuity A has an ordinary annuity. That means it starts at the end of the period. There's your 5 cash flows. Annuity B is an annuity due. So it's going to start today with its 5 cash flows. So the question that we have for these two particular problems is, are these cash flows, are they equal? Are they the same? Well, obviously they're not the same. However, we also need to understand, well, which one's going to grow to the larger amount? And I'm going to try to get us a shape here so I can make some circles here for us. If you look at these cash flows here, and I'll have to expand this a little bit for you. These cash flows, these middle 4, the first 4 cash flows here, and these 4 cash flows over here. These cash flows are identical. They happen the same years. They're the exact same amounts. So there's absolutely no difference on what their future values will be and or their present values today based on the formula or based on the cash flows. What's different, though, are the other 2 cash flows. This cash flow down here happens 5 years from now. This cash flow here happens today. So an annuity due will always grow to a larger amount than an ordinary annuity because one of its cash flows is going to grow for the entire investment time. So annuity due for investments grow to larger amounts. You can calculate the future value of an ordinary annuity, right? To place an annual cash flow. You can use this formula, of course, but as before, the R in this formula represents the interest rate. The N represents the number of payments in the annuity, right? So again, it's spread out over time. And again, I'm just kind of going through this formulas a little bit so you can understand how they're calculated, right? It's 1 plus the required return to the nth power minus 1 divided by that required return. So this is what you would refer to as the interest factor. Multiply the payment times that, and you would end up with the future value. So let's take a little example here. Let's talk about Fran Abrams' example. And this is the annuity, that's the ordinary annuity. The cash flows start at the end of the year. So now if you see, we're going to need to go back to our time value model. We're going to have to go back. Nope, now it turned off. So we're going to have to go back to the, come on. Waiting for my computer to work. It's not liking me right now. Let's go back and talk about this. If you go back, we're going to go back to that time value model, the time value cash flow spreadsheet, and here we input our data. The interest rate 7%, the time is 5 years. It's annual payments, so the compounding frequency is 1. Now here's where we talk about the annuity. Is this an ordinary annuity? In that box, you will click a Y because it is an ordinary annuity. In fact, that is the default for this box. If you want it to be an annuity due, you have to change that to an N. So the payment that we put in there is $1,000 because she's going to invest $1,000 a year for 5 years. The future value is $57.50 and some pennies. Let's see if we can get our time value thing working here again. There we go. Now we can do it, right? So again, we put our negative investment, negative 5,000, one time per year, 5 years, and we're using a 7% interest rate. So 7%. Oops, I'm sorry. It's negative 1,000. That makes it a better difference. And there's our future value of an annuity number. So I think that's pretty straightforward to understand how you calculate that. Now, what would the value be if it was an ordinary or an annuity due? All you would need to do is change this Y to an N. So before we do this, before I click the button, what will be true about this future value of an annuity if I change this to an annuity due? And if you remember from the previous slide, it will be a bigger number. So we will have a greater future value. So you change the N and hit enter, and now as an annuity due, it's 6153. So we have we've looked at some examples about how these things work. We're just working our way through the process. How do you find out the present value of an ordinary annuity? Again, it's 1 minus, and now we have 1 divided by 1 plus R to the nth power. And I don't know if you recognize this, but this is the present value interest factor. So if you subtract that from 1, multiplied by the cash flow divided by R, that will then ultimately give you the present value of this annuity. And as you can see, the formulas are a little bit on the intense side. So Braden Company, they produce plastic toys. They want to determine the most it should pay to purchase a particular annuity. The annuity consists of cash flows of $700 at the end of each year for 5 years. The firm requires the annuity to provide a minimum return of 8%. So again, how do we change this formula? And again, we know it's an ordinary annuity because it says at the end of the year, 8% is the interest, 5 years is time, compounding once a year because it's annual payments. Now down below, here's the trick. For payments, we have to tell them whether we're going to be receiving the cash flow or paying the cash flow. In this case, we're going to buy the annuity so that we receive the cash flow. So in this case, again, I don't need to go to the time value spreadsheet to show this, but if you go back to this case, you find out that we have 2794 is the present value of this annuity. So that is the most they should pay to purchase this particular investment. Well, that's the end of part 1. This is kind of a long chapter, so I wanted to split it into 2 parts. I'll see you in part 2.